Hey guys, so today we will be talking a little bit about what numericals we can do in terms of acceleration. Okay, there will be a few sums at the end of the chapter. Before we get into that, I want to talk a little bit about uniform acceleration. Okay, so uniform is simply the same acceleration, right? So to understand that, I simply have this small diagram here. Okay, something going from A to B to C to D to E. You notice that for every 5 seconds gap, look at the change in speed, 30 to 40 in 5 seconds, right? So that is 10 increase, right? Increase of 10 kilometers per hour in 5 seconds. So if I have to say acceleration, I'll say simply 10 divided by 5, which is nothing but 2. Right? So you see that by 2 kilometers per hour per second speed it is accelerating over here. Even here it's the same. From 40 to 50 it's again 10 in the same time. So this is nothing but uniform acceleration. Okay. So whenever we talk about numericals, we talk about acceleration being uniform, just that the acceleration is changing at a steady rate, that is all. Okay, now I have written one sum here. If the handwriting is not clear, I'd ask you to go to page 29, example 2 in your physics readers. Okay, it's the same sum I've taken from the reader. We are going to solve this today. Okay. To solve these sums, anything related to acceleration, will only need 3 formulae. Okay, only 3 formulae which I have written at the top right corner. V equals to u plus at, s equals ut plus half at square, v square minus u square is 2as. I'll tell you what each term is. U is nothing but as initial velocity. Initial means starting. What is the velocity in the starting? V is nothing but final velocity, meaning velocity that is in the ending. A is acceleration, as we know. S is nothing but displacement. If you remember, if you're talking about velocity, we talk about displacement only, no, not distance. Finally, T is nothing but time. Okay, so these 5 values are will be there somewhere in the sum. You need to figure them out and use them to solve for what they want. Okay. Now in this sum it is saying that there is a signal light. Okay, there is a signal light like a red light, and 400 meters away from it brakes are applied to a locomotive. Okay, so there's a locomotive means like an engine, train engine. Okay, so to draw it, say that there is a light over here. Okay, this is 400 meters of distance between this and the train engine, however you draw it. Okay, when the distance is 400 meters, the train is putting his brakes down. Okay, when you put brakes, what happens? The vehicle starts to become slow, right? Which means acceleration is going to be negative. If you remember yesterday's class, we saw acceleration reduces, right? The speed reduces means acceleration becomes negative. Okay, in this, that what we say is, if my acceleration is negative, it means it's in the opposite direction of my velocity, meaning I'm going front but my speed is reducing, my acceleration is towards the back. That is why the object will stop at some point of time. Okay, now he has given us u value already, initial velocity. Now what is he asking us to find? Determine position of rest of locomotive relative to signal light. Okay, meaning once you start hitting the brakes, this is going to stop somewhere. He's asking you where is that going to stop, how far from this signal light will this train stop, locomotive train. Okay, after how much time did he say? 1 minute. Okay, so in 1 minute of time of applying brakes, where will that object stop? Okay, he also gave us the value of acceleration, which is again, like you said, see, negative number, right, meaning it is becoming slow. Now the first thing I'll do, I'll write down every value that is given to me. Okay, I hope you have written this down because I need this space to write. Okay, so I'll figure out what values are given, then what values I need to find. U is given to me as 54 kilometers per hour. Now what else is there? Distance of 400 meters. Okay, time is 1 minute. Okay, what is this given? Acceleration is given, minus 0.3 meters per second square. Okay, I don't have V, I don't have S. Okay, actually V I know, V is supposed to be 0 kilometer per hour. I am saying 0 because ultimately what's going to happen to that object, it's going to stop, right? So that is why I'll say V is 0, final velocity is going to be 0. Now he's asking me how far, what's the position from this object. So the first thing I'll do is I need to figure out what is this displacement, how much displacement is going to happen for this object. Okay, now notice one thing, my acceleration is in meters per second square, but my velocity is in kilometers per hour. So the first thing I'll do is I'll change this to meters per second. So to change kilometer per hour into meter per second, we simply multiply it with 5 by 18, which will be nothing but 15 meters per second. Okay, so initially the velocity is 15 meters per second, finally it comes to this 0. Now we need to figure out how to find S. Again I'll look at the formula over there. Alright, so let me figure out how long it takes for this object to stop. Okay, so one formula I have is V equals to U plus AT. Okay, now I know time is given 1 minute, but how much time is it taking to stop, we need to see. So I know V is equals to 0, I know U is nothing but 15 plus A, that is minus 0.3 into T. Okay, so now I will take this 15 to the other side. Minus 15 equals to minus 0.3 into T. Okay, now this is multiplication, so I send it that side, it becomes division. Minus 15 divided by minus 0.3 equals to T. Now I'll just switch these places, A equals to B, B equals to A, it's the same, right? So I will say T equals to minus and minus cancel. 15 by 0.3 nothing but 150 divided by 3, which can also be written as 50. Okay, 50 seconds. So the time taken for this to stop is 50 seconds. However, they've asked us to check after 1 minute. So now I know that time is 50 seconds. I need to now find what is the value of S. Okay, I need to find what is the value of S. So one thing I can do, I can use this or this. Either way, I will get the same answer. I will just use this formula because that is simpler. Okay. V square minus U square equals to 2AS. Now I know what is V, U and A. I need to find S. So I will say V is 0, right? 0 square minus U square, that is 15 square, equals to 2 into A, which is minus 0.3 into S. Okay. Now 0 square is 0, minus 15 square, so minus 15 square minus 15 square equals to 2 into 0.3 minus 0.6 into S. Okay. Now again I will cross multiply. Minus 15 square divided by minus 0.6 equals to S. Again I am switching the sides just to make it look neater. S equals to 15 square divided by minus minus cancel, so 15 square divided by 0.6. 15 square is nothing but 15 into 15, or I can simply write 15 square as 15 into 15 divided by 0.6. 3.2 is a 0.6, 3 5 is a 15, right? Now 15 5 is 75, so this will become, I'll just write it here, 75. Sorry, I have a small board. Yeah. S equals to 75 divided by 0.2, it's nothing but 750 divided by 2, so that is nothing but 375 meters. Okay. So from here, once you hit the brakes, it's going to cover a distance of 375 meters before it stops. Now, if full distance is 400 and it's covering 375, how much is remaining? I can see this, it's asking us from the signal light, right? So I need to measure this distance. So I can simply say distance is nothing but 400 minus 375, which is about 25 meters. So just within 25 meters of the signal, my train is going to stop. It looks lengthy, complicated, but trust me, this is very easy. Only 3 formulae. You need to figure out what is given, then find out what is not given. Just matter of understanding the sum properly. We'll practice more of these. I'll give you some probably examples and stuff. Go through the reader, and this would be a very scoring part if you know how to do it. Okay.